We're back at sequences and series, arithmetic ones. Sequences are the set of numbers. Series are when you add them up. Here we have a series of numbers, but they have k's involved. They have k's added to them. A little bit more complicated, throws us off. But if you just follow the same formulas, all the k's will drop out. Everything will work out in a nice way. They want to know the sum of this series. We don't know how many terms it has. We do know something, though. We do know the first term, T1, is 4k. And we know this last term here, whatever that is, Tn, is 74k. What else do we know about it? Well, if you look at the difference here, notice you add how many k's here? 7 here. You add 7 here. We don't have any other terms, so the difference, the common difference, is 7k. Always check it for each one just to make sure. We can't check it any more than that. 7k, first one. So we could figure out how many terms it takes us to get to 74k. Just follow the same formula. So the nth term is equal to the first term, or a, plus n minus 1 times the common difference, n being the number of terms. 1 is the first term. Here's 1, here's 2, here's 3. So let's calculate. Since we know what this is 74k. That's the last term here. Is equal to 1, which is 4k, plus an unknown, n minus 1, times the common difference. We said that was 7k. This is equal to 4k plus 7k times n, 7k times n, minus 7k. Here we have two of these. So I'll get out of the way in a second. Here we have 74k, here we have a 7k, and an 8k. These two, here we have a 7k and a 4k. These two will add up to a minus 3k. These two here, minus 3. Take that to this side. We're going to add 3k to this side. That would be this one and this one. I hope I didn't do that too quickly. That would make this here 77k, which is equal to 7kn. N being your unknown number. Well, notice here now you've got a k on both sides. We can cancel out the k, divide both sides by k, because k doesn't equal 0, or this whole thing is meaningless. And then we divide both sides by 7. And you have n equals 11. So we know now this is the 11th term. I can write that in there. You could have actually counted. You would have been counting for a little while. Now we found out what the last term is. It's n is equal to 11. We know the first term. We know the last term. We can use one of our sum equations because we want to find the sum of this. So the easiest one to use here is the sum of n terms is equal to the number of terms times the first term plus the last term all over 2. Whatever the value of n is in here. So in this case, n is going to be 11. So this is going to be 11. So the sum of the first 11 terms, some people might use the sum, n equals 1 to 11. People use different symbolism for this. Don't let it confuse you. How do we do this here? Well, we put 11 in for the n, and then we do the first term, which is 4k. Don't forget the k. Plus the last term, 74k. All divided by 2. There we go. 74k plus 4k is 78k. So 78k divided by 2 times 11. 70 divided by 2 is 35. You're going to add 4 by dividing this, so this is going to be 39k. 39k. You can tell it's about 40 times 10. The answer is going to be about 400k. Let me check my calculator. I am coming up with 429k. Pretty close to my estimate, so I know I'm probably on both of these. So the sum, or the sum of n terms, where n is equal to 11, in this case, is 429k. I hope that helps with this series where we're not just using numbers but letters as well. Check out my next video, and I'm going to have a couple of more longer form answers for the same sequences and series.